Зараз. Секунду, підготую все для шерінгу екрану. Так, починаємо. Share screen. Start recording.
Recording in progress.
Про що ми сьогодні будемо говорити? Ми починаємо велику тему Kubernetes, але ми не просто будемо дивитися на Kubernetes як Kubernetes, ми будемо дивитися як Kubernetes для мікросервісів. Тому що самі мікросервіси дали йому поштовх для розвитку. І ми будемо дивитися в тому числі на базі Kubernetes, як адресувати певні челенджі для мікросервісів, які я минулого разу називала. Значить, сьогодні ми почнемо саме з самого базового поняття, що таке под в Kubernetes. Ну, там буде под та deployment. В чому різниця? Ну, Давайте почнемо. Значить, також зразу скажу, що я буду використовувати Pluralsight, тобто іноді в нас будуть відосики з Pluralsight. Вони також будуть записані, я записую їх, ви це бачите, і в запису, який буде опублікований на Google Class, то відосик з Pluralsight, він теж залишиться. Так, ну що, давайте тоді почнемо. Значить, в нас, я називала... Зараз, пауза, можливо, є якісь питання? Окей. Минулого разу я називала декілька викликів для мікросервісів. І 3 з них, вони можуть бути адресовані за допомогою Kubernetes. Це deployment, а також це entry point, і також це питання, як сервіси будуть знаходити один одний. Ну, по всім цим моментам будуть деталі. Ну, давайте. Цю картинку ми минулого разу розглядали, що таке оркестратор контейнерів і що Kubernetes – то є оркестратор контейнерів. Також казали про те, що є там різні оркестратори контейнерів, і наш фокус буде на Kubernetes. Також дивилися на цю картинку, що оце як оркестратор, там на нодах, ось це там ноди, і тут там буде докер обов'язково, ми також розглядали, що таке докер взагалі, і тут будуть всередині, ось оце біленький контейнер, це докер-контейнер, і в одному поді, ось що таке под, з точки зору Kubernetes, ми сьогодні і будемо розглядати. Тобто в одному поді може декілька контейнерів крутитися. І я казала про кейс з сайдкаром. Зараз я про це швидко кажу, але ми до всього того підемо в деталі. Тобто нічого страшного зараз, тобто ми до того ще будемо повертатися. Так, значить, давайте я навіть ось як зроблю ось ці челенджі. В нас були челенджі, і ми будемо дивитися на певні конструкції Kubernetes. Значить, і тут давайте тобто, чому ми саме ці конструкції Kubernetes розглядаємо? Тому що в нас якраз є челенджі, і ми шукаємо, як ці челенджі адресувати. Ось, тобто ми розглянемо в Kubernetes поди, та все, що зв'язано, там трошки складніше, ми розглянемо поди. Потім в Kubernetes є така конструкція, як сервіс і інгрес. І ось ми це розглянемо, а щоб це було трошечки більш візуально, поди окремо, значить, інгрес – це точка входу, а сервіс – це можливість звертатися до поду, не до поду напряму, бо под може вмерти, і буде новий под, і де він буде знаходитися, не зрозуміло. А ось через такий проксі, як сервіс. Тобто, ми три моменти, ще раз повторюю, ми розглядаємо поди, сервіси, тобто ми розглядаємо поди, сервіси та інверси. Ось це ми розглядаємо. Ось це наш фокус. На декілька найближчих лекцій. Тобто сьогодні тільки поди. Так, зараз буде трошечки плюрал сайту, це якраз сайт з технологічними курсами, в мене є підписка на нього, і саме тому я з нього показую. Насправді я не знаю, чи можу я так робити, але так роблю. Я думаю, що погано в тому немає. Так, значить,
по-моєму, лише PowerPoint бачимо, чи ви
я перешарю. Значить, вам знадобиться Kubernetes. Де ви його можете взяти? Ви його можете взяти, поставити собі міні-кюб, тобто йдете на сайт Kubernetes, качаєте собі міні-кюб, і буде у вас такий маленький Kubernetes-кластер на вашій машині. Тобто, взагалі, Kubernetes може управляти декількома машинами, але міні-кюб, він саме якраз для таких тестових цілей, тобто тільки ваш комп'ютер, і там ви всередині все запускаєте. Тобто він тому називається таким міні-кюб. Якщо у вас недостатньо, тобто ви скачали міні-кюб, і у вас недостатньо, ви розумієте, що повільно, не вистачає ресурсів, то йдете в Google Cloud, бо Google Cloud теж насправді надає Kubernetes. Так, тепер пішли на сайт. Зараз. Давайте ще раз я...
All right, well, let's jump into a little bit more about pods.
Секундочку. Я ще раз перешарюю скрін. Ви маєте чути саунд зараз.
And some of the core
Чи чути саунд?
Так.
Так, чути.
Добре, значить, це буде
Зараз вас не чутно.
Так, дякую, я зам'ятувався. Ага, ми подивимося на всі відосики, а ось концепт Creating Pod. Так, зараз, щоб я... Ну, в принципі, ну, ось весь цей розділ ми подивимося, можливо, не сьогодні, ну, тобто, можливо, не все сьогодні, але здебільшого будемо сфокусовані на цьому розділі. Ну, давайте почнемо. Ой, ні, я не хочу ніякі сирої, дякую.
concepts that you need to know. So first off, Kubernetes defines a pod this way. A pod is the basic execution unit of a Kubernetes application, the smallest and simplest unit in the Kubernetes object model that you create or deploy. So it's the basic building block. If you think of Kubernetes as a bunch of Legos, we're going to put those together, and kind of at the foundation of all this is pods. Pods, as we've already seen up to this point, run containers. And we're going to talk about it is possible for them to have more than one container, but we'll get to that in just a moment. So let's back up a little and start with, we know pods at this point are the smallest object in Kubernetes. Pods act as an environment for containers, and it's really important then to think of pods as a way to organize the different parts of your application. And as a developer, this absolutely can influence how you might write your Docker files that generate the containers and what type of code you put in those. Normally we have a single process per container, and oftentimes we'll have a single container per pod. And that would mean if you had a web server, caching server, maybe multiple APIs, and you could be even containerizing your databases, then each one of those parts would be a separate pod, and that would be important to plan for, of course. Now, a pod has an IP address, memory, volumes, and all of that can be shared across multiple containers within the pod if needed. We can scale pods out horizontally on a node. And pods live and die, but they never come back to life. So if Kubernetes sees a pod that's unhealthy or sick, it can automatically remove that and then replace it. And we're going to talk more about pod health towards the end of this module, actually. So if we break it down, we've already talked about how a master node is going to schedule pods on a node. And we call that node a worker node. Now, if we kind of zoom into that, we know now that our pods can be horizontally scaled as well. And so we can create what's called replicas. And these replicas, they're really just copies or clones of the pods. And then Kubernetes can load balance between those. Now, if one of these pods gets sick, Kubernetes will monitor that and can automatically take it out and then put something back that's a healthy pod. Now, as I mentioned a moment ago, it's not bringing back to life the pod. The pod that was sick is removed from the node, and then a new one is brought to life. And that keeps everything healthy. Now, pods within a node are going to have a unique IP address. And this, by default, will be a cluster IP address, it's called. And then the containers within pods can then have their own unique ports. So pod containers share the same network namespace. They share the same IP. Now, they are going to use the same loopback network interface within a pod. That's localhost. So if one needs to talk to another, that's going to be very simple and just using that local loopback. Now, container processes within the same pod need to have a different port. The pod itself gets a unique IP address, but the ports, if you had multiple containers within a pod, need to be unique. Now, in this example, you can see off to the right that we have two pods. Each container then has a port 80, and that's okay because they're in separate pods. We have different IP addresses, and it's okay to have 80 and 80. Now, if you needed to have multiple containers within a pod, which is more rare, but it is possible. The example would be if you have a container and then another one is very tightly coupled, needs to be scheduled at exactly the same time because they work together. We call that oftentimes a sidecar container. Then in that type of scenario, each of those containers within that single pod would need their own unique port. Throughout this course, we're going to go with the typical one container per pod approach, but it is absolutely possible, as mentioned, to have multiple containers in a pod, but you need to plan for that accordingly. Now, ports can be reused, as I've already mentioned, between containers in separate pods, and that's not a problem at all. One thing that relates to IP addresses and pods and containers is that pods never span nodes. They're always on a single node, and they can't do something like this. That would be a little difficult, especially with IP address management and more. So that doesn't happen within Kubernetes and isn't something you really ever have to worry about. So that's a quick look at some of the core concepts. Now let's jump into how do we work with creating a pod. So how do you get a pod up and running in Kubernetes? Well, there's actually several different techniques that you can follow, and we're going to look at a few of those here. So one thing you can do to run a pod is to run kubectl run. This is a quick and easy way to get it going, but it's more of what we call imperative way. Later, I'll show you how we can use YAML, actually define an official file, and then use kubectl to move that deployment with the YAML to Kubernetes in more of a declarative way. That way you can check it into source control and things like that, whereas the kubectl run, that's just an imperative command. Now, the other one we're going to look at with the YAML file is going to be the create or apply commands of kubectl, and we'll get to that a little bit later in the course. Going back to the kubectl run command that you can see here, you'll notice that we can give it a pod name, and this can be any valid name, and then we can give it the image of what we want to run. Now, there's other command line switches as well, but these are the main things you need to know just to get started if you wanted to start up this pod and then run this Nginx Alpine container inside of it. Once you have one or more pods running, you can then use kubectl get pods. Very simple command. And if you want to display all resources, you could use kubectl get all, which we talked about earlier in the course. As a pod is brought to life, it's going to get a cluster IP address. Now, a cluster IP address is only exposed to the nodes and the pods within a given cluster, and it's not accessible outside of the cluster. So what do we do if we brought up Nginx, for example, or ASP.NET Core or Java or whatever you're doing, and now you actually want to test that locally, maybe from your machine, into Kubernetes on, say, Docker Desktop or Minikube? Well, we need to expose the pod port to be able to get to it. And in order to do that, we can run a kubectl port forward command, give it that pod name that you just saw earlier, and then we can give it ports. Now, the ports here are very similar to how you work with ports in Docker. The 8080 would be the external port, what you would hit if you wanted to call this from a browser, for example. And the 80 would be the internal port, and that would be the port that the container is actually running on inside of the pod. But what it does is it exposes that port through the node so that we can then call into it. And this is kind of the most basic way that you can do this port forwarding, they call it. Now, once a pod is running, if you'd like to delete it, you can call kubectl delete, list the type of the resource, which is pod, and then the name of the pod. Now, what's interesting here is while the pod will be deleted, if you go do a get all or get pod on kubectl, all of a sudden the pod comes back to life. And if you didn't know about it, the first time you do this, you kind of think, oh, the delete didn't work. But if you look closely at the IDs that are issued to the pods, you'll see it did indeed change. Kubernetes just saw the deletion and automatically replaced it. Because remember, it wants to keep you at the current state you're at. If you want to officially delete pods and not have them come back, you'd have to delete the deployment that originally scheduled the pod. Now, we haven't covered deployments yet. That'll be upcoming in a later module in the course, but we could run kubectl delete deployment, that's the name of the resource, and then list the name of the deployment. So now that we've covered some of the basic commands, let's see if we can get a pod up and running quickly with kubectl. Now let's take a look at how we can use some of these kubectl commands to get a pod up and running, and then I'll also show you how we can delete it and a few other commands along the way. So I've opened up a PowerShell window, and the first thing I'm going to do is let's make sure Kubernetes is running appropriately. So I'm going to say kubectl enter. Let me scroll back to the top of the commands here. This will give you all the different commands, at least the key commands you can run. One of those is run. We're going to do that momentarily. If I scroll on down, you'll see delete. We're also going to delete a pod. And then if we come on down a little further, you'll see port forward. And we're going to do a port forward as well so that we can actually load up an app in a browser that's running in Kubernetes. So the first thing we can do is we can type kubectl, or if we use the alias like I talked about earlier, we can just say k. I've already configured that. And we could say get all. And right now, there's really nothing going on. We have a cluster IP, you'll see. We'll be talking about services a little later in the course, but really nothing going on as far as pods go. So what do we do to get a pod going? Well, that's where we can use kubectl run. So I'm going to go ahead and type that, kubectl or k, either way. And then we're going to go ahead and give it a name. I'm just going to call it Nginx or maybe my Nginx, doesn't really matter. And then I'm going to say, what is the image that we want to run? Well, I'm going to say -- image. So we're going to give it a flag there, equals Nginx Alpine. That's the specific Docker image that I want to run inside of this pod. So let's go ahead and hit enter. All right, now it says that pod's being created. So let's verify that. We can do get pods. And notice that we have my Nginx. 1 of 1 is running, 0 restarts. We're kind of good to go. Now, I want to emphasize this is a command that's a quick and easy way to get a container running in a pod. It's not something that more than likely you're going to use a lot, especially once we learn more about YAML and some other options. But if you just want to get something running, it's great for that. Now, let me go ahead and switch over to a browser, and let's try to hit it on localhost because Nginx runs on port 80 inside the container. And let's just hit enter, and it's spinning, but it's not looking so good. And that's because it doesn't know how to get to this pod because we've never exposed an external port at all. If we go on back here, and if we just do get services, then you'll notice we have a cluster IP, but cluster IPs are internal only. You can't get to them externally, so we need to kind of poke a hole, if you will, in Kubernetes to expose a port that we can call in the browser, which then calls into our Nginx container in the pod. We know that the pod name is my Nginx, so what we can do is a little port forward command. So I'm going to type k port forward, and then give it the pod name, which is my Nginx. And the next thing I want to do is very much along the lines of what you do in Docker, where you have an external port and then the port for the container. So the external port is 8080, let's say, and it could be any available port on your machine. But we know that Nginx runs on 80 inside of the pod in that pod's container. So I'm going to go ahead and hit enter. And notice it sets up this forwarding now from 8080 to 80. And let's change this now. Instead of trying to hit 80, let's go to 8080. And there we go. We obviously have Nginx running and we can access it directly through the browser, but that wouldn't have worked without the port forward because the IP address that the pod is being assigned inside of Kubernetes is not accessible, but the port forward makes that possible. All right, so that's nice to get started.
Я тут зроблю паузу. Хочу додати коментар, що ось цей сценарій з портфорвардингом, це виключно такий дебагінг сценарій. Це не продакшн сценарій зовсім. Тобто в цьому відео робиться демо пода, і ми хочемо пересвідчуватися, що под буде працювати. І ми ніяк не можемо цього зробити інакше, як port forward. Але це зовсім не продакшн сценарій, так не роблять. Це тільки демо чи продакшн сценарій. Продовжуємо.
Let's go on back. And you'll notice it locks up the console. So if I wanted to see my pods or see what's happening, I'd have to actually open another console, or I'd have to kill the port forwarding. So I'm going to do a Control-C here to kill that. And then the last thing we want to do is let's just get rid of the pod. We know it's running, so we'll clear this real quick. Let's do k get pods again. There it is. We've already seen that. Now, the next thing I can do is delete the pod. So I can say kubectl or k, delete pod, and then give it the name, MyEngineX. Let's go ahead and delete it. All right, now that's deleted. Let's do the get pods command. No resources are found. Let's verify that. We'll just go ahead and hit enter here. And notice it's spinning, and it'll give it a few seconds here, but it'll fail. And there we go. Connections refused because there's nothing listening on 8080. So that's a few of the basic commands that get you started. Let's review these commands really quickly here. So first off, we did kubectl run. We gave it the name of the pod, whatever you want to call that pod. And then we gave it the image that we want to use for the container that's running inside of that pod. From there, we did kubectl get pods. We saw we had our pod running. Everything was good there. But we saw that we couldn't access it directly because there was no IP and port that was exposed externally on our machine. So we fixed that with kubectl port forward, gave it the name of the pod, MyEngineX in the example we just did, and then an external port, which is 8080, and an internal port, which is 80. And the last one we did was kubectl delete. We give it pod. Now you do have to put pod here because there's other resources that we're going to learn about throughout the course that you can also delete. So we have to be very specific that we want to delete a pod. And then we gave it the name of the pod, MyEngineX, in our demonstration. So those are some basic commands to get you started. And while you may not use kubectl run every day, it is good to know about it because it's a quick and easy way to get a pod running. Now to wrap this up, I do want to mention one more thing. If you're on Kubernetes 1.18 or higher, then kubectl run will do exactly what I just showed you here. If you're on an older version, it will actually create other resources like a deployment. And we're going to be talking about deployments coming up. So just kind of know that older versions of Kubernetes, this command was a little bit different. So if you're on, 117 or something like that, you may actually see additional information generated, additional resources generated. Whereas if you're on 1.18 or higher, a newer version of Kubernetes, it only creates the pod and that's it. So that's a few of the key commands to get started with. And while those are good, there is another way we can work with pods. And so let's talk about YAML a little bit and how that plays into all of this.
Давайте трошечки зробимо паузу. Можливо, є якісь питання? Був такий імперативний запуску подів. Окей, тоді рухаємося далі до YAML.
Up to this point, you've seen a more command-centric approach to creating pods in a Kubernetes cluster, and that's more of what we call imperative. What if you want to move to a more declarative approach, where we could actually use some type of a language to define our pods and other aspects of Kubernetes? Well, that gets us into something called YAML. Originally, this stood for yet another markup language, but nowadays it's called YAML ain't markup language. That's the official terminology. Now, YAML is nothing more than a text file that's composed of something called maps and lists. In fact, you'll see that YAML ties in very nicely to JSON, except for in JSON, you would have things like brackets and commas. You don't have that in YAML, as you'll see in a moment, but the concept of a key and a value, and then a sequence of items, an array, is very similar here to a map and a list. Now, indentation is going to matter here, and you're going to need to use spaces for the indentation. There's no brackets, so there's no kind of I'm done with this section like we're used to in other languages. In YAML, you simply indent things, and that determines when a section ends and when another one starts. Now, you can have key-value pairs. We refer to those as maps, and maps can even contain other maps if you'd like to create more complex data structures. You can also have a sequence of items, and that would be called a list. And then you could have a sequence of maps, actually, in a list. So here's what YAML looks like from a high level. You'll notice first off at the very top, we have a key followed by a value. So this could be first name, Dan. And that would be called a map. You can also have complex maps, and here would be an example of one called complex map that has key 1 and key 2. Key 1 is just a simple property, if you will, and then key 2, you'll notice, has a sub, which is subkey and its value. Next thing we can have is a sequence of items, much like an array, and you put the dash in front of each item. And then finally, a list could be used to actually create a sequence of maps. In this case, I have a map 1 with different properties and a map 2 with different properties. Now, I want to call your attention to the note at the bottom there because, as I mentioned already, indentation really matters. This is probably the number one thing that'll throw you off if you're new to YAML. And use spaces, not tabs. And once you pick how many spaces you want to go with, for instance, maybe I use 2 spaces, then make sure you're consistent at each level of your nesting. So now that we've covered the basics of YAML, let's see how we can use it to actually describe a pod. Okay, so we've seen the basics of YAML, so let's put this into practice and apply it towards defining a pod. So the first thing we'll do is we'll create a YAML file for our pod, and I'm going to show you the format of that file in just a moment. But then we can run that through kubectl, run a specific command or commands, and then that will generate a pod running in our cluster. Now, I want to emphasize that what I'm going to show you here is certainly a viable way to create a pod. However, later, as we move into deployments and replica sets, I'm going to show you a different technique that's actually more commonly used. But since we haven't covered those yet, this is good to know, and it will give us some experience with YAML. Now, this would be a look at a very simple YAML file for an Nginx pod. You'll notice I called the file nginx.pod.yaml. The extension, by the way, can be YAML or YML. Either one works. It's really just a text file anyway, but certain editors will give you better IntelliSense or code help or code coloring based on that file extension. Now, in this example, you'll notice I have a map, API version, and v1. Now, this is something that is defined in the Kubernetes documentation, so you would need to go dig into that to learn about all these different maps and the different lists that I'm going to show later as well. The kind is really important. What kind of resource are we trying to create in Kubernetes? Well, obviously we're creating a pod, so that's what we put in this case. Now we have a complex map called metadata, and we're going to name this my Nginx. That will become the name of the pod. Next thing we're going to do is have what's called the spec. This is the specification, if you will, for what's going to go in this pod. Think of it as a blueprint. And in this case, we're going to have containers, just one, and it's going to be called my Nginx as well, and the image is going to be Nginx Alpine. So that would be a very basic definition for a pod, and you can see that it contains the major aspects. It has the names we need, as well as the image for the container that's going to run inside of that pod. From here, we can take that YAML file and use a kubectl create command, as you'll see here. But what we need to do is use either a -- file name switch, or I just use the shortcut -f switch. So in this case, we're going to say -f, name of the file, .pod.yaml, and then we can actually do some validation of the YAML. Now this kind of is the default, where if you try to run some YAML that's invalid, it will actually give you some errors. But you can set -- validate to false if you'd like, in cases where maybe you don't want to validate the YAML. I normally leave everything on as the defaults. Now the dry run that you see will actually perform kind of a trial, if you will. So instead of actually affecting the cluster, you can try the command and see what it would generate in the output, see if it's valid, and then from there, you could go ahead and run it if you'd like. So as mentioned, it'll validate by default, but I put this in here so you know how to turn that to false if you ever needed to for some reason. Once you're ready to actually run the command for real, then you can just remove the dry run and the validate and do a create -f, give it the file name. What that will do is now take that YAML, send it up to the API service of our master node. Ultimately, it gets converted, and then that will be stored inside of the master, and that will start the scheduling process by the controller. What happens, though, if you run kubectl create and that particular pod already exists? Well, in that case, you'll get an error. There is another option though, which we're going to talk about in just a moment, and that will allow us to do the same type of thing, but simply override the pod if it's already there. But a create will give you an error if that pod already exists. So an alternative to running kubectl create is kubectl apply, and then we can still use the same -f and give it the file name. I prefer this almost always because this allows me to do two things. I can, first off, create the resource using this, but I can also update an existing resource using apply. Now, in order for the update part to work, if somebody would have used to create that resource in the first place, and they have that pod up and running, you would want to add --save config. Now, what this will do is create some annotations, which I'll show you next, so that when we do apply later, it will take whatever we're trying to apply, compare it to what was there in the first place, and then we can override specific settings. So, very important thing you'll want to do if you ever use create. As mentioned, I typically will just go with apply anyway when I create, but either technique works, and everybody has an opinion on this, of course. Now, if you do the create with the save config, what that will do is add some annotations, which will have all the information about the YAML file that was last run. That way, once that pod gets up and running for that first time, we have the initial state. Then, if you do an apply later, it can override that initial state, and it kind of knows what that state was. So that's an example of the save configuration. And then, as I mentioned, having this in place makes it easy to then work with this. Now, there are other options here. There is a kubectl edit. This will actually let you edit the file for your resource, a pod, a deployment, a service, whatever it may be, right in the console. You can also do kubectl patch if you'd like to patch a particular property. Maybe you don't want to make multiple changes. You just want to update a very small subset of things. Then kubectl patch could be used for that. Now, we looked at how to delete a pod earlier, and you can do kubectl delete, give it the pod and the pod name, but if you did YAML, you could also do it this way. You could use kubectl delete and then use the -f switch to give it that YAML file. And that would be an alternative way of deleting it if you don't want to worry about getting the name of the pod. So now that we've looked at how you can use YAML to create pods, let's look at a quick demonstration of taking a YAML file and applying it into our cluster using kubectl.
Тут ми зробимо перерву. Значить, зараз 11:05, ми зустрінемося в 11:10. Ну ось, давайте тоді робимо паузу.
Recording stopped.
Так, повертаємося. Повертаю запис.
Recording in progress.
Повертаю скріншерінг. Значить, ми зараз додивимося відосик демку про створення подів з ямлів, а потім подивимося про дуже цікаву тему, яка називається Pod Health. Починаємо.
We've seen how to create a pod YAML file and some of the commands. So let's experiment with those commands and a few others and see how we can get that YAML into the Kubernetes cluster so we can get a pod up and running. So I have a pod YAML file here for Nginx already set up, very similar to what you saw earlier. You'll notice the API version, the kind, I have some metadata, and then down below I have specs, and I have my Nginx Alpine container. Now the only thing that's really new here is I've added a labels in the metadata. Now right now these labels aren't doing anything, but I want to bring it up because later they will. Once we get to things like deployments, or services, or even other resources in Kubernetes, we can link resources to each other through labels. So a deployment or a service could reference this label, and that would tie those two together. So later on, once we get to those topics, I'll go more into labels and how those are going to be used, but for now, I've just made up two labels, app and rel, and given them values. Now the other thing is I've defined ports here. Now the default port for Nginx is 80, so this is kind of overkill. But I wanted to show that you can define the container port here as well. Now to get this running, we know that we can run our create command. And so we can come down and say kubectl create, and then we could run that if we'd like. So let's go ahead and do that. Now I'm going to abbreviate it though to just k, create, and then we'll give it the path. Now in this case, I'm kind of a little deeper. So I'd have to say samples/pods, and then our file name. Now, I'm also going to add a save-config, and I'm going to show you why I'm doing that in just a moment, and we'll come back to that though. So let's go ahead and do this, and we should now create a pod. Let's do k get pods, and there we go, we have the pod. We can't get to it right now, but you now know the port forward command with kubectl, so we could certainly make it accessible. Now, the next thing I'm going to do before we go into the describe I'm going to show you is, let's do a get again on the name of the pod, which I called my Nginx. And again, you'll see that name right up here. So we'll do that. But I'm going to add an output of YAML, or I could do JSON. Now, I think the YAML is actually a lot easier to read in this case. So I'm going to output that. Notice I get kind of a big output here. And at the very top, there's these annotations. Well, that's what the save config did right here. Was it added the current version of the YAML, converts it to JSON internally, but that way, if I ever make modifications, it knows the starting point. And so we could come in and, for instance, change the image, maybe to a different version of the image, and then we could apply those changes. It would then compare the image it currently has, which is just the current version of Nginx Alpine, and then override that and get a new pod and container up and running. Now, another way I can get insight into our pods is through something called describe. So we could say kubectl describe pod, and this will give me a dump of information again. You can get all kinds of information about it, what node it's on, when it was started. You can get things like the IP address of it, Docker image, container, more. But if we scroll on down to the bottom, you're going to notice some events. Now, I'll give you a little hint. We're going to have a troubleshooting section at the very end of the course, but this is a really good one to look at because different failures that occur can also show up. But let's look at ours. We first off assigned this pod to the Docker desktop cluster. It didn't need to pull the image, Nginx Alpine, because it's already present on the machine. It created the container inside of the pod, and then it started the container. And every little change we make to this will be tracked here. So describe is great for getting information not only about the pod and the container and image, but also about the events that have occurred. So I use this quite a bit when I want to look at what's going on. Now, let's say that we did come in and we changed the image. I'm actually not going to here, but we could run this apply command. So I could say kapply file, and this can be used to either create the resource, create the pod, or to apply changes to that. works either way. So in this case, I'm just going to go ahead and we'll pretend that we made some changes. And now I'll give it the same path. And we'll go ahead and run that. And notice it said it was configured, not created. Now what's nice about apply is if it wasn't there, it would create the resource. If it is there, it'll apply any changes to the resource. Pretty nice, actually. Now there are limits on what you can change. There are some things like ports. That's a different story, and you'll get an error if you try some of that. But you could definitely change things like the container image, and there's other settings as well you could change. Now, moving on down, let's say we now have this pod running. If we do k get pods, we've already confirmed that. And now let's say that we'd like to get into the container of that pod. Now in Docker, you can use a docker exec command to do that. In Kubernetes, we can do the same thing. We can say exec into the name of the pod, my nginx. I'm then going to use the interactive TTY. This is basically a way to say I'd like to shell into it with an sh shell. And now I am in there. And we could jump down in nginx to where the home page is loaded, for example. So we could say, go to usr/nginx/html, I believe it is. And then we could do an ls, and there we go. There's our index.html, and we could even modify that just to play around. But normally you would redeploy the image in the container, of course. So let's exit out of there. Now we could even do an edit here if we wanted. And I'll show you what this command does. So kubectl edit, we'll give it our path again. And you'll notice this actually popped open my editor. So I can now do an edit here live if I'd like. And of course, what it opens will be different based on if you're on Mac, Linux, or Windows. But in this case, I'm on Mac. So if I hit Control-C, it'll kind of tell me what I need to type to get out of Vim. So we can do this QA bang. And now I'm out, but I could actually save it local and make changes. Now, the final thing is we've already seen this, but if I do get pods again, we have our one. And if I want to delete it, this time, because we don't have a deployment, it will delete the pod. Now, I can actually delete it by the name, or I can give it the full path to the YAML again. I'm going to go ahead and do that just so you can see it works. And now you'll notice if I do a get pods, it's gone. We'll do a get all. And you can see I'm just back to my normal Kubernetes service. So to do a quick review, we talked about kubectl create will create the resource, and then you can save the initial state of that with save config. That way you can apply changes later if you'd like. Create is optional. You can also use apply, as I mentioned. Now, kubectl describe, very important if you want to dive kind of deeper into what is the pod, what IP address does it have, what image did it use, what container ID does it have, and things like that. Plus it has the events that I showed. Apply can be used to create or apply changes. Now, if you're applying changes and somebody used create, you'll want to make sure they did the save config again. We can exec or shell into a pod container. Very, very useful sometimes, especially if you want to debug or tweak something just for testing purposes. Showed you the live edit if you want to write in the console, make an edit to your YAML. And we know we can call kubectl delete and either give it the pod or we can give it the YAML file that originally created it. So that's an example of several of the different pod commands that you can run. We'll be seeing more and more as we move along, but this will kind of start to build up your knowledge of different ways you can use kubectl.
Окей, а тепер, можливо, є питання по подах. Добре.
Можна загальне питання?
Да.
А у Kubernetes у нього немає якогось клієнта, типу десктопного, для зручної роботи?
Значить, дивіться, в Kubernetes є командна строка, командний рядок, ну, як побачили, і в нього є UI, але той UI більше для відображення, що в тому Kubernetes є. Якщо ви будете в Google Cloud, то у вас там буде UI-чик, щоб працювати. Відповіла?
Ну, в загальному робота через термінал, да, виходить?
Да. Насправді там достатньо зручно через термінал. Оці YAML-файли, дивіться, тут насправді трошечки більша тема, дякую вам, що ви її підняли. Справа в тому, чому ми взагалі про ці YAML-файли говоримо, тобто ми почали з команд, потім перейшли на YAML-файли, і чи YAML-файли, чи UI, гарне питання, але я хочу ось в наступному контексті його затронути. Коли ми з вами розробляємо інфраструктуру, тобто deployment – це частина інфраструктури. І неважливо, хто її буде розробляти, деви, і там якусь, тобто девопси чи якусь частину будуть все ж таки робити деви, бо питання, ми там дивимося на Kubernetes, хто це все робить, деви чи девопси. Інфраструктура теж має бути як код. Тому YAML можна покласти в GitHub, а div UI не можна покласти в GitHub. Тому ось саме ми так на YAML дивимося. Тобто навіть ось ці create pod, get pod через такі як команди, вони не використовуються, це більше такий debug стайл. А ось саме YAML – це продакшн сценарій. Я відповіла?
Так, зрозуміло, дякую.
Угу. Наступний момент, на якому хочу зупинитися, це, от ми казали про те, що оркестратор контейнерів дивиться за тим, чи там всі контейнери, в нашому випадку поди, чи всі вони живі та здорові, родичі гарбузові. І питання. Можливо, ви вже стикалися з тим, що коли ви пишете веб-застосунок, то в нього є health endpoint. Чи стикалися ви з тим? Давайте тоді я скажу. Давайте я тоді це заінтродюшу. Зараз. Так, тут багато. Так, поки голосом, а потім підемо в деталі. Значить, питання таке, як ми можемо дізнатися, чи... Давайте так, я розумію, що ми кажемо про контейнер, але давайте все ж таки в контейнері крутиться наша програмка. Як ми можемо дізнатися, що наша програмка працює? Тільки зробивши певний виклик і отримавши результат окей, результат success. Зазвичай для того роблять спеціальний endpoint, його називають health, і той health endpoint буде казати там окей чи не окей, чи взагалі не відповідати. І ось тут питання. Ось тут починаються дуже цікаві деталі. І давайте зараз я хочу підняти декілька станів таких. Стан перший. Стан перший, наш застосунок працює прекрасно. І контейнер теж тоді там працює прекрасно. Все гаразд. Але момент номер один. Наприклад, навіть, знаєте, я, мабуть, навіть слайд зроблю, щоб це продемонструвати. Зазвичай він так і називається health. Там можливі варіанти, і респонс буде я не готова зараз дати демку, на наступних парах я дам цю демку, а зараз не готова дати цю демку. Але за допомогою статус-кодів ми зрозуміємо, чи там окей, чи не окей, а в баді просто, якщо якийсь компонент не працює, то ми з баді зрозуміємо, який саме. Тобто, дивіться, що саме можна рахувати нашим, тобто наш health складається з певних компонентів. це сам наш застосунок плюс dependencies. Давайте так. Ну, наприклад, веб-застосунок працює з базою даних. У нас може трапитися ситуація. Сам веб-застосунок працює, але база даних чомусь тимчасово недоступна. Питання. Але пам'ятаєте, чому я про це все зараз кажу? Наше питання зрозуміти, чи под, тобто наш застосунок крутиться в поді. І нам треба розуміти, под здоровий чи ні, коли треба той под вбити і новий запустити. А так ось, ситуація. Якщо веб-застосунок крутиться, з ним все окей, але база даних тимчасово недоступна. Чи треба нам вбивати под?
Ну, оскільки це стороння залежність, то ні.
Так, ви праві. Тобто, насправді, це база даних недоступна. Але, все ж таки, тут таке є питання, але, все ж таки, наш под не функціональний. Тобто, хоч і він не працює, але свою роботу end-to-end він не може виконувати. Що нам можна зробити в цьому випадку? Що можна кубернетесу зробити в цьому випадку? Щоб не дати користуватися якимось таким не зовсім функціональним компонентом, але при тому ж под здоровий. Ваші варіанти.
Ну, от видавати може якраз статус-код, що там щось не зовсім ок, і в боді писати, що датабаза не відповідає, чи там щось таке.
Да. Ось саме тут ми так і будемо робити. А я маю на увазі, давайте як... Дивіться, ще раз, ситуацію, zoom-out. В нас є под, там крутиться застосунок. Застосунок, він, в принципі, з ним все окей, його не треба перезавантажувати, бо він працює. Але база даних не працює з якою застосунок. Тобто застосунок там звертається до бази даних і, і нічого не відбувається, база даних недоступна. Я хочу до чого підвести, що насправді в цьому випадку Kubernetes такі речі розрізняє. Він... От якраз що є в Kubernetes? Kubernetes розрізняє ситуації, коли є liveness, в нього є дві такі ситуації: liveness та readiness. Liveness – це, под там взагалі не може працювати, то його треба рестартувати. Тобто под взагалі не відповідає. А readiness буде означати, що под, в принципі, здоровий, але він ще не готовий. Тут може бути дві ситуації. Ситуація, що под запускається, тобто він в процесі запуску, і ситуація якраз, коли база даних, наприклад, недоступна. Тобто він не ready. Тобто він якби live, але він не ready. І коли він не ready, ми просто трафік будемо на нього не пускати. Ми запревентимо тим самим, що користувач не зможе виконати операцію, яка, база даних не працює, ми ж нічого зробити не можемо. Тобто ми не дамо користувачу користуватися нашим сервісом, але в той же час ми уникнемо ситуації, коли ми постійно будемо рестартити той под, а справа не в поді. Тобто, наприклад, у нас є база даних. Наприклад, у нас з тією базою даних працює 20 подів. База даних недоступна. І починає Kubernetes ось ці 20 подів перестартовувати, а база даних ще недоступна, а ті поди він знову починає перестартовувати. І, коротше, ось такий меднес з того рестарту виходить. Тобто, така собі ситуація. Так ось з цими двома маркерами liveness і readiness можна достатньо гарно розробити цю ситуацію. Роблю паузу. Що скажете? Чи є в тому сенс? Чи зрозуміло, про що я говорила?
Загалом так. А тобто у нас є декілька подів ідентичних, і от з одним там, проблема, і тому ми туди трафік не пускаємо, а пускаємо в інший. Чи як? Бо якщо ми просто зупинимо трафік, то у нас і застосунок не працює наш.
Дивіться, тут от ця ситуація, яку я описую, вона до кожного поду застосована. Тобто, ми можемо опинитися в ситуації, якщо, наприклад, база даних всіми використовується, і всі поди від неї залежать, і вона тимчасово недоступна, то так, трафік ми перестанемо пускати на усі поди. Ми можемо опинитися в такій ситуації. Бо, в нас temporary outage буде. Але це, тобто, якщо база даних недоступна, то ми ж нічого зробити не можемо.
Окей. Щодо readiness, то воно, здебільшого, чи прям зовсім взагалі відноситься лише external dependencies, чи там readiness може і про сам под щось казати?
Зазвичай це external dependencies. Сам под, там в readiness, ми подивимося, там буде, зазвичай поду дається певний тайм-аут на те, щоб прийти в ready. Тобто там не відразу, подивитися, тобто readiness складається ось з проби, є така readiness probe, тобто саме readiness probe, тобто запит про readiness і поду дається певний час для того, щоб прийти в себе. Чому
це саме на початку, коли він запускається, чим чекаємо, що він готовий, а потім це, власне, здебільшого зовнішні штуки.
Чому я почала говорити про health endpoint? Тому що тут дуже важливо, щоб ваш health endpoint матчився з цими readiness, health and readiness probe від Kubernetes. Тобто, щоб, коли ви будете настроювати под, ви в ньому, там далі буде в YAML, ви кажете, де readiness probe, де liveness probe. І не можна сказати так, щоб ви на readiness probe сказали, що тут вам треба буде дати два ендпойнти. Тобто зазвичай просто сервіси, так ось як склалося, що сервіси дають один health, але для Kubernetes треба буде дві проби робити в сервісі. Це мають бути різні проби. Тому що поведінка Kubernetes різна на цій ситуації. Тобто один health endpoint, який видає і сервіс сам по собі, із залежностями, тобто воно тут не підійде. Тобто тут треба буде дві проби, дві health-проби. Одна для liveness, друга для readiness. Так. Ось якраз я і кажу, що цей слайд присвячений для того, що нам треба буде зробити два ендпойнта. Так, давайте подивимося відосик на те саме, про що я казала, про ці проби. Вони з демкою цей момент. Я так розумію, покажуть.
The final topic we're going to cover is related to pod health, and this really can tie into you as a developer. Kubernetes relies on something called probes to determine the health of a pod container. And a probe is just a diagnostic performed periodically. Now, why would we as developers care? Well, because obviously we're going to know the most about the code running in that container, and therefore we could help either write the probes, or we could help maybe an administrator who's writing the YAML, if they're doing it, add the probe that is appropriate for that pod and container. Now, there's two types of probes. You have what's called a liveness probe. Basically, is it alive? How's it doing? And then you have something called a readiness probe. Now, a liveness probe, as mentioned, is used to determine the health of the pod. Is it sick? Is it healthy? A readiness probe, on the other hand, helps Kubernetes determine when it should start sending requests. So when is it started so that we can actually start talking to this? As mentioned a few times up to this point, if a pod itself is deleted and has a deployment behind it, then it can be automatically recreated and the container is recreated. Now, if the container in the pod, though, fails one of these health checks, then it can be restarted. And there's a restart policy that defaults to always. You can override that. But that would allow you to control if that container restarts or if it just fails. Now, what types of probes do we have? So let's imagine we have these containers, as you see here, running in the pods. How do we know what's going on there? When it's ready, if it's healthy, if it's sick, things like that. Well, of course, it really depends on the software running in the container. If you'd like, you can actually execute a direct action in the container. So you could run a command, for example, and as long as it returns 0, then that's successful. You could perform a TCP type of check on the IP address of a port and see if that's successful. Or if it's an HTTP type pod and container, then you could perform some type of HTTP request. Now, probes only have the following results. They can be successful, they can fail, or we can have an unknown response. Now, let's take a look at how in YAML you would actually define some of these probes. So let's first take a look at a liveness probe. A liveness probe, as you see here, is used to check how are we doing health-wise. Well, if it was an HTTP server, maybe it's an API, it could be Nginx just serving up static files, the only way you can really know is to call into that and get some expected response. Now, as a developer, this is where we might actually write a health API of some type that the kubelet could actually call into. Now, this could be an API, it could be a health check built into your target framework. It really depends. But in this case, you'll see we're going to define a liveness probe that's going to be an HTTP GET type of liveness probe. Now, we're going to say you need to check index.html on port 80. And as long as that returns within the status code range that I mentioned earlier, that'll be considered successful. Because obviously we're going to know the most about.
Я хочу трошечки до того, зараз я збила, я хотіла на паузу поставити, збила. Ай-яй-яй. Так, загубилася. Зараз. Ось тут, про цей індекс HTML. Так, секунду. Ось, я хотіла сказати, бачите, в цьому прикладі вони сказали індекс HTML, а також він сказав, що це може бути health endpoint згідно вашого фреймворку. В сучасному стані речей індекс HTML, веб-застосунки не мають індекс HTML, а фронтик іде окремо, а бечик іде окремо. Тобто в бечику не буде цього індексу HTML. Тобто в бечику буде певний health endpoint, і ми про нього вже говорили.
You need to check index.html on port 80. And as long as that returns within the status code range that I mentioned earlier, that'll be considered successful. Now, we're going to wait 15 seconds for that because it may take a second for this pod to come up and the container. We're going to have a timeout after 2 seconds. And we're going to check every 5 seconds. And then allow one failure before failing the pod. So by working with these different settings, this is really, really good for us as developers, and your admins are going to love you as well, Because now there's a way where you can control what determines if we're healthy or not. And that's really up to you. Now, if you're not writing the YAML at work, you still probably are responsible for whatever the health check is that the YAML and the kubelet would actually call into. And that's where I think we as developers can play a big role. Now let's take a look at another example of this. Now this is pretty much straight from the documentation. Let's say that we're going to define some args that are going to run in a container. We're going to shell in, do a command, and we're going to touch something called healthy. Now we're going to sleep 30 seconds after that's created, and then we're going to do a rimraf, which is a remove, if you're unfamiliar with that command, of that healthy. Now what the liveness probe is going to do is it's actually going to try to get to the healthy. We're going to run a cat command on healthy, and that'll determine if we're alive or not. Now what'll happen is it'll be alive for the first little bit, then healthy would be deleted, and then it would fail. What would happen there is, in this case, we would automatically bring up a new container after it fails. And of course, we can have an initial delay and a period of seconds on when it checks. So these are the types of things you can do to actually work with liveness probes. And there's others, of course, you can do. But the bottom line is you can exec a command. You can run a TCP/IP type of request to that container in the pod. Or you can do an HTTP GET type of request. Now, when it comes to readiness probes, this determines, again, when should traffic start being routed to a pod and its associated container, because if we start sending traffic too soon, it may not be ready yet. So in this case, we're going to see if an Nginx container is ready in a pod by doing the same thing we saw earlier. We're going to do a get to index.html. If that returns a good status code, then we're good to go. Now we're going to wait 2 seconds though, and then we're going to check every 5 seconds until it's up and running. So to summarize these, a readiness probe is when should a container start receiving traffic, whereas a liveness probe is when should a container restart because it's either not alive or it has some health issues. Very, very important to know as you're not only programming your app, but also as you're defining the YAML for your different pods. Let's take a look at pod health in action and see what happens with our pods and containers. So I have a similar file open to what we saw earlier in this module that's related to Nginx and the pod YAML. You'll notice we have a liveness probe and we're doing an HTTP GET to the index.html homepage on port 80, and then we have some timing here for initial delay, how often to check, and things like that. Now I also have a readiness probe that really does the same thing. Now what I'm going to do is mess with the index.html a little bit. Now let's go ahead and apply this. We'll do the apply-f, and we'll do .yaml, and we'll get that going. So it should be done by now. And all right, there we go. Now, the name of this particular pod you'll see, let's run that one more time, is my Nginx again. So let's go ahead and describe it with describe pod my-nginx. And you'll notice down here that we successfully assigned, the image was present, and we created the container. So not a whole lot of bad stuff at this point. Now let's go ahead and exec into this, and we'll do our -it sh. All right, and now I'm going to go down into some subfolders here. And from here, if we do an ls, you'll notice I have an index.html. What if we were to come in and, let's say, part of our program, remove that file? So we'll do an ls, and it's gone now. You'll notice command terminated here, and we're back actually out. Well, let's see what happens. So we'll go to k-get pods. You'll notice it's running. But let's now go to k-describe pod. And look at that. Container my-nginx failed liveness probe. Well, that's exactly what we'd expect. Now, let's go back and exec in one more time, and let's see, are we on the same thing? Are we on something different? What do we have? So we'll go in, and we'll go to usr/share nginx html. All right, well, we must have a new one because look at that. Our index.html is back, so our container is back. And that means it was restarted. And that would be an example of how these work. Now, let me go ahead and we'll get rid of this one. And the next one I'm going to run is similar to what you saw earlier. And this has some args in it that are going to touch this healthy file, sleep 30 seconds, remove it, and then sleep longer. And then what we're going to do for our liveness probe here is actually do a cat on healthy. And obviously if that doesn't work, we have a problem. So let's see what happens here. And we'll get this going. All right, so let's make sure it's running. Okay, it looks like it's still getting ready. Notice the status, by the way, is container creating. Okay, so we're going to let it wait a little while here. And while it's kind of running, let's go actually back because I didn't grab the name. Let me copy this and let's describe it. So we'll do a K describe on that pod. And you'll notice everything's looking good here. Start a container, liveness, create a container, liveness. Everything's pretty good. Now we're going to wait just a little bit. And let's see what happens because, again, behind the scenes, after about 30 seconds, we should be doing a delete. And then we're going to sleep a while. So I think we're getting pretty close to that. So let's do a kget pods. All right, so everything looks good there. Let's run back to our describe. And there we go. Container liveness failed liveness probe will be restarted. And so that container is now being taken care of by Kubernetes. And I happen to think that's pretty cool. I don't know about you, but it's pretty exciting stuff, actually. And we should be all set. So that's an example of how we can work with a liveness probe and a readiness probe. And you can see how powerful this is because it'll ensure that your container within the pod is restarted as necessary. But that's an example of how we can work with our different probes.
Вибачте, можна питання?
Так, треба.
А можете, будь ласка, повернутися туди, ну, крайній його файл великий?
Sure that your container within
Будочок?
Да, ось тут якраз. Ось там, де args, да, аргументи, там, де, що це за флаг там у нього, мінус, ну, dash C, 17 рядок. Wow.
До речі, не знаю, що це dash-C.
А цей touch, що він робить?
Touch, значить, дивіться, touch, він, ну, це як ми, коротше, він файл створить. Чи директорію створить. Тобто touch, це один спосіб створити.
А 16-й рядок, це він, типу, заходить в директорію в цю, він...
Значить, він запускає, тобто, як ми, ну, тобто, це SH, тобто, ми будемо, ну, SH-клієнт, термінальчик.
Угу. А RM, типу, потім він видаляє цей файл?
Так. Тобто, він створив, потім видалив.
А Healthy це є файл, чи це папочка?
Так, давайте.
І ось цей cat.
Ні, це має бути файл, бо cat – це надрукувати. Тобто, коли ми кажемо команду cat, це ми просто друкуємо зміст файлу на екран.
Тобто він зробив якийсь файл, потім попробував, ну, постукався на нього, а потім цей файл удалив, і у нього упав цей код.
Да.
Зрозуміло, дякую.
Угу. Я ще хотіла один момент. Можливо, ви звернули увагу, він ось тут десь в рядочку терміналу робив зараз. Зараз. Покажу цю операцію, просто зверну вашу увагу на ту операцію. Він робив exec. Тобто можна, ну, тобто це операція Kubernetes, коли ви, ось, бачите, ось, зараз ми якраз до того. Ось, exec. Тобто ось ця операція, насправді, Kubernetes дозволяє знавігуватися, тобто ми можемо зайти всередину пода, ну, всередину пода. І, ну, тобто, далі ви бачите, він тут тобто, зайшов, а далі просто виконує там ЛС, роздрукувати там директорії, ну, тобто, певні операції може зробити. Знову ж таки, це не продакшн сценарій, а це більше такий дебагінг сценарій, але там іноді вам треба зайти всередину. Ну, це аналог того, як ви можете зайти, ну, тобто, якщо у вас докер раниться, і ви можете пригнути всередину докер-контейнеру і подивитися, чи є там файли необхідні. Ось це такий самий сценарій, те саме ви можете за допомогою Kubernetes робити. Ну так, сфокусувала увагу, що це можливо. Так, значить, дивіться, що ми сьогодні розглянули. Ми з вами розглянули сьогодні поди. Ми сьогодні з вами розглянули health, ось ці readiness and liveness проби. Але ну, в нас залишилося 10 хвилин. Значить, в нас є наступна тема, вона називається деплойменти. Я думаю, що ми вже її сьогодні чіпати не будемо, ми її почнемо наступного разу. Тобто вона, ось наступна наша тема буде працювати з деплойментами. Це така надбудова над подами. Ну, сьогоднішню лекцію трошечки раніше завершимо. Чи є якісь питання? Так, треба.
Цей курс ми не можемо так дивитися, це у вас, ви маєте тільки доступ до цього курсу, так?
Да. Ну, це платна підписка, я її оплачую, тому...
Ніяких плюшечок для студентів, типу, нічого такого немає? Не може бути?
Я не шукала, чи є там плюшки для студентів. Це Pluralsight, ну подивіться на сайті, на Pluralsight. Я знаю, що для КПІ Курсера відкрила частину курсів, але ну, про Pluralsight не знаю. Я взагалі не знаю, чи він так робить. Він якось більше не з... От якось він не з академічною спільнотою працює. В нього дуже багато саме технологічних курсів саме від інженерів, не від університетів.
А можна тоді ще попросити запустити оцей останній підсумок, чи як він називається, файлик?
Ви маєте на увазі пересопритись?
Ні, ось відео, зараз ми зупинились на Pod Health.
Давайте. Да, добренько.
Let's wrap things up with a quick review. So we know that pods are the smallest unit of Kubernetes, and containers are then going to be hosted within pods. And if you had multiple containers in a single pod, they would share that pod's memory, the IP, volumes, and really anything else that's part of the pod. Now, pods can be started using different kubectl commands. We saw kubectl run, and we also saw how we can use YAML and combine that with kubectl create or kubectl apply. Now, health checks are a really, really important part of this because if you end up running a lot of containers up in Kubernetes, we'd want to know if they're healthy and when they're available to accept traffic and things. So we also talked about how you can do pod health checks and add in those probes so that you know when a pod and its container is actually healthy or not.
Дякую.
До речі, ну, я зупиняю відосик, запис, я маю на увазі, я зупиняю запис. До речі, хочу вас запитати, як ваш експірієнс з тим, щоб слухати ці відео? Ви не засинаєте?
Та ні, норм, в принципі.
Окей. Добренько. Any last minute questions? Тоді бажаю вам гарного, спокійного дня, спокійного тижня і побачимося через тиждень.
Дякую.
Да.
До побачення.
До побачення.